Hello everyone. In this session of CCNA series, I'll discuss about radio frequency, also known as RF. Wireless technology is rapidly evolving and is playing an important increasing role in our daily lives throughout the world. Ever thought how those wireless devices communicate with each other without any physical medium like cable to carry the signal along? Then how does wireless communication transmit signal across the air or free space? The answer is antenna. Every wireless devices are equipped with antennas. Antenna is responsible for the transmission and reception of signal on such devices. Antennas are electrical devices that transform the electrical signals to radio signals in the form of electromagnetic waves. Electromagnetic waves do not travel in straight line. Instead, they travel by expanding in all directions away from the antenna. To get a visual image, think of dropping a pebble into a pond when the surface is still. Where it drops in, the pebble sets the water surface into a cyclic motion. The waves that result begin small and expand outward, only to be replaced by new waves. In a free space, the electromagnetic waves expand outward in similar way. You can take an example of a simple idealistic antenna that is a single point at the end of a wire. The waves produced expand outward in a spherical shape. The waves will eventually reach the receiver. At the receiving end of a wireless link, the process is reversed. As the electromagnetic waves reach the receiver's antenna, they induce an electrical signal. If everything works right, the received signal will be a reasonable copy of the original transmitted signal. Electromagnetic waves are measured using frequency. Frequency is equal to number of cycles per second. That is, number of times the signal makes one complete up and down cycle in 1 second. A cycle can begin as the signal rises from the center line, falls through the center line, and rises again to meet the center line. Just like the ripples on a pond after a stone has been thrown into it, all the little ripples that pass through a certain point would indicate a frequency. Suppose that in a second the signal completed 4 complete cycles. So its frequency will be 4 cycles per second, or you can say 4 Hertz. Hertz, also known as Hz, is the standard unit of measurement used for measuring frequency. Since frequency is measured in cycles per second, 1 Hertz equals 1 cycle per second. So radio waves that is ranging from 1000 kilohertz to million megahertz or to billions, also known as gigahertz of cycles per second. Any frequency range from around 3 kilohertz to 300 gigahertz is commonly called radio frequency. The range is utilized by different types of common radio communication devices such as television, AM and FM radio, radars, and wireless LAN communication routers using 2.4 and 5 gigahertz. To wrap this up, let me summarize it this way. Wireless communication takes place over free space through RF or radio frequency. One device, transmitter, sends signal to other device, that is the receiver. Two devices, transmitter and receiver, must use same frequency or same channel to be able to communicate with each other. That's it for this session. I hope this was informative for you.